Hello guys, welcome back to the channel. Today we are going to solve this Leetcode question, which is squares of a sorted array. It is an easy question, and in this question we are given an integer array nums which is sorted in non-decreasing order. Non-decreasing order is basically ascending order. So written an array of the squares of each number sorted in non-decreasing order again. So the question is very easy to understand. Like, we're basically given an array of integers which is in ascending order, and we need to find the squares of the elements of sorry we need to find the squares of each element in the array, and we need to return the values the sorted order as well. So if you look at this example, we're given this array, and when we square this it will become, oh, they have given right here, right? When we square this array it will become 16 10900, and we need to sort it, and we need to return it. So, and if you look at this example as well, when we sort the elements, it will become 49 9 4 9 and 121, right? So this is not in sorted order, so we need to sort it and we need to return it, right? So, if you look at the constraints, the number of elements can be a maximum of 10 power 4, and each value can be negative as well as positive. So what's the most brute force approach that comes to our mind when we see this question? So the most brute force approach that comes to my mind after seeing this approach is that, I'll just create a new array and store the squares of each element in that array, and now sort the new array. Basically we're given this array, and I'm just storing the square of each number in this new array, and I'm just sorting it. So in this way, we can find the solution of the question. And since the length is only 10 power 4 at most, so this might get accepted, but this is not the most efficient solution, because in this case the time complexity will be, for copying each and every element into the new array, it will take order of n, plus sorting this new array will take order of log n, the worst case. So the time complexity is order of n log n. And when it comes to space complexity, you might say that we can directly square the elements in here, and we can also sort the elements in this same array. It doesn't matter, right? So if you do that, it will take order of 1, but if you use a new array, it will take order of n. But it is recommended that the array which has been given to you must not change it, right? You must clone it to a new array, and you must modify the newly created array instead of modifying the data that has been given to. So if you tell this approach to an interviewer during an interview, he might not be happy with the solution, and squaring he might say that squaring each element and sorting the new array is very trivial, means it's very inefficient, and could you find an order of n solution using a different approach? This is a follow-up that the interviewer might ask us. So let's try to optimize the solution. So if you let me take an array and come back. So let's look at this example. So when our array only contains positive integers, then if we if we square each element directly, then it will give the resultant array, right? Which will also be in the sorted form. But if you look at this example, when we have negatives, if I square each and every element, then the resultant array will not be in sorted order. So we need to sort this again in order to make this array to be a sorted array, right? So the problem arises when we have some negative elements in the array. So how are we going to solve this? Means, you observe carefully in this array, we need to find the smallest element, right? If you observe in this array, the smallest element is in the middle, right? Which is 1. And the next smallest element is either it can be this or it can be this. Because minus 2 square is also 4 and 2 square is also 4, right? So the next smallest can be either of these. So let's say I took this, and what's the next smallest element? Then the next smallest element will be this, right? This 4, and the next smallest element can be this or this, right? So if I take this as my next smallest element, then this will be my next smallest element, right? And let's see these examples as well in order to get better idea. If you look at this example, the smallest element lies in the middle of the array, right? Which is 4. 2 square is 4, right? Then the next smallest element can be this or this, right? So let's say I took this, then the next smallest element is this, then the next smallest element is this, then the next smallest element is this, right? So let's also look at this example. So the first smallest element is in the middle, and the next smallest element is this, next one is this, next one is this, the next one is this. So you might have found a pattern in this. So I thought of starting from the middle and find the leftmost, compare the elements which are on the left and the right, and you know what I mean, right? So I thought of doing like that, but it doesn't work when the length of the array is even. When the length of the array is even, the thing that I told you right now, it doesn't work. But what we can do is we can do the same approach in an opposite manner. So if you observe carefully here, the least element is the middle one. So what are the maximum elements that can be in this array? Either this or this, right? So we know that either this or this can be my maximum element. So let's say my maximum element is 100 initially, and then my maximum element is 16. It is 4 minus 4 square. Then the next maximum element is 9, and the next maximum element is 1, and the next maximum element is 0. So we're getting the sorted array, but we're getting in the descending order. So we need to again sort it, but we can also do it in a different manner in order to directly get the sorted array. What we can do is, since we know the maximum element, we keep the maximum element at the end of the array, 100. Then we get the next maximum element, 16. Then we get the next maximum element, which is 9. Then we get the next maximum element, which is 1. Then we get the next maximum element, 0. So what we're basically doing is we're just using two pointers. Let me explain you with this example. Initial, I'll keep my pointer here and another pointer here. So I'll check in within these two pointers which one is greater. 11 is greater, right? So 121. 11 square is 121. So I'll keep it at the end of the array. And then this pointer moves inwards, right? This pointer gets decreased. This pointer moves to this point. And then I'll check between these two. Minus 3, 3 and minus 7, which is the greater one. In terms of squares, 7 square is greater or 3 square is greater. Minus 7 square is greater, right? So I'll keep 49 here. When I include this element, I'll move this pointer towards the right. So next my pointer goes to here. Now which one is greater, minus 3 square or 3 square? Either of them can be greater, right? So I'll take this one as my greater element, and I'll move my pointer towards left. Now between 2 and minus 3, which one is greater? 3 square is greater, right? So I'll take this and I'll move my pointer here. Now both the pointers are on the same element. So I only left with 2. So 4, and one of the I can either move this pointer here or I can either move this pointer here. So in any case, my left pointer will become greater than the right pointer. So my left pointer will come on the right side. When my left pointer crosses the right pointer, then I will stop and I will have the resultant array. So this is the approach that we are going to follow. Let's look at the same thing with another example. Let's say we have an array of, say we have -7, -2, 1, 8, and 9. Let's say we have this array. We know that the maximum elements can only exist on the boundaries, right? So this is my left and this is my right. So what I'll do is I'll check which square is greater, 9 square or -7 square. 9 square is greater, right? So at the end of the array, I'll keep 9 square and I'll move my right pointer towards the inside. So this will become my next pointer. So which one is greater, 8 square or 7 square? 8 square, right? So it will become 64 and I'll again move my right pointer towards the. Now which one is greater, -7 square or 1 square? 7 square, right? Which is 49. Now it will move towards the outside. My low is, I'm sorry, my left is this, my right is this. Which one is greater? -2 square, right? Which is 4. Again, this value moves. Now both the pointers point to the same element. Now, which since both the pointers point to the same element, we'll copy the square of this element, which is 1, and my left pointer moves towards the right. So my left comes here. So when the left pointer crosses the right pointer, then we can stop and we have the sorted array. So let's see how we can implement this solution. So initially, as I have already said, I'll have int left equals to 0. And my right will be on nums dot length -1. So I'll take a build array, new int of, or let's say the name of the array as square or squares. That's fine. Dot length. Now what I'll do is while my left is less than or equals to right, if my mat.abs means even if it's negative, it will give the positive value. If it's positive, it will only give the positive value. Suppose mat.abs of -4 means 4. Mat.abs of 10 means 10. Mat.abs of 3 means 3. And mat.abs of -1 means 1. It will give the positive value. That's it. So nums of left, mat.abs of nums of left is less than or equals to, it should be greater than, right? Greater than mat.abs of right. Then what I'll do is initial I'll keep a pointer at my pointer is at nums dot length -1. What I'll do is my squares of I'll keep sums of left to left. I'll decrease my index and I will also Since my left one is greater, I'll increase my left, right? Else what I'll do is squares of I equals to num of right to nums of right. Now I'll decrease my x, but now I'll increase my right. Oh, I need to decrease my right, right? As I've already said, the right value will be decreasing from like this, and the left value will be increasing like this. And we'll keep a I here, and we'll keep on decreasing I till our I reaches this point, right? The same thing we are doing. The I always keeps on decreasing like this, but the left value will be increased from left to right, and the right value keeps on decreasing. The right value keeps on decreasing. At the end, I'll just return the squares array. Just run this. Do table. Okay. Submit this. Uh, it got accepted um, with 1 millisecond as the runtime. So let's discuss the time and space of this. The time complexity of the solution is order of n, right? Since we are only visiting each and every element of the array only once, and the space complexity is, if you consider this additional the resultant array as a additional space, then the space complexity is order of n. Otherwise, it's order of 1. Since they want us to return the you know a sorted array, if we consider this as a additional array, then it will be order of n. Otherwise, we are not using any extra space other than these variables. That's it. So this is the most efficient solution that we can solve this question with. So that's it, guys. Thank you.